So in this, we'll be coming across the sliding window protocol. So in sliding window protocol, we'll be coming across these terms: piggybacking, sending window, or receiving window. Piggybacking. So to understand this concept, piggybacking, we'll go back to the previous flow diagram. Okay. Now, suppose sender is sending frame 0, receiver has received the frame 0, and accordingly, receiver has sent the acknowledgement. After sending the acknowledgement, now receiver want to prepare the answer for this information. Okay. So receiver want to reply for this with some new information, reply information to this. This is only acknowledgement. Now the receiver want to send a reply for this. So he will prepare the reply for this, and reply will be sent maybe at this point. So after sending the acknowledgement, after some time, so reply will be sending. That means unnecessarily two different frames are being moving from receiver to the sender. So instead of sending acknowledgement separate and reply separate, why can't the acknowledgement is delayed till the reply is prepared, and why can't this acknowledgement is included along with the reply? Okay. As a result, this unnecessary movement of the acknowledgement will be avoided in the network. That part, the network traffic can be reduced. So by thinking that if the receiver delays the acknowledgement and includes the acknowledgement along with the reply frame, so if the receiver is following this concept, then it is called piggybacking. Okay, so instead of sending the acknowledgement separate and again reply separate, so why can't the receiver combine both of them as a single frame for sending the reply and acknowledgement? So this concept is called piggybacking. Okay, that is about the piggybacking. Next is sending window or receiving window. So for the sending and receiving windows, suppose I am the sender, for example. I am communicating with, say, some person A. So whatever my communication, whatever I want to send to A, that information I have to store in my data link layer. That data link layer needs some buffers. So depending on the availability in my system, some buffers are being allocated for the communication with A. Okay, some buffers are allocated in my system for communication with A. So how many buffers are allocated? That is my window size. Suppose after sending one frame, maybe the number of buffers available with me may be more than earlier or maybe less than earlier, because if some other task of which already I am doing is completed, maybe I can allocate those resources to this task if I want. Then the number of buffers available for communication with A will increase. So my window size is increased. Suppose while communicating with A, if I had to do some important task, a mandatory task, for that I need to allocate some resources. So maybe some of the buffers already allocated for A, I am removing them and allocating for some other task. Now the number of buffers available for communication with A will be reduced. Now thus new window size is reduced. Okay. So in over a period of time with communication with A, the number of buffers available for communication with A are being changing as per the need, as per the requirement. So the number of buffers are being varying. That is why I can say my varying number of buffers is called sliding window. Because so in our house we may be seeing, if we move the sliding window more, the more gap is opened for air passage. So window size is more. If I close more, less gap is available for airflow. So window size is reduced. Okay. So overall window size is indicating the overall capacity of the memory that I am having in my system. But effective usage, if you close more and open less, only that much air will flow into your room from outside. That is the effective window size you are using. If you open more, more air will come, more air will go. So that is the concept used. That because of that concept used, so the name sliding window is given to this. Okay, so this may be happening both at sender side and at receiver side. Even the same thing will happen at the receiver. So receiver, at the beginning of the communication with a receiver is going to allocate some buffers. Over a period of time, after exchanging certain number of frames, maybe due to some other reasons, whatever number of buffers are allocated for communication with a may be varied or may be changed, may be reduced or may be increased. That means the window size at the receiver also changing. That is the meaning of sliding window. If it is sender system, sending window, receiver system, receiving window. That's how the terminology is coming across. So these are the other concepts we may be coming across in our next set of protocols. So that is why this is appropriate time to discuss about these terminology. So we are next is now in this particular example, we'll take a small example of communication between a sender and a receiver. So these are the four diagrams, diagram A, B, C, D. So diagram A is having these two, one for sender clock and other is receiver clock. Diagram B is sender and receiver. So upper 4 indicate the sender window, lower 4 indicates the receiver window at appropriate times. Okay, 4 different stages. So initially A, the diagram A indicates at the sender position, initial position, nothing transmitted. Okay, nothing transmitted. So two edges of the pointer, two pointers are overlapping in this. So what is the indication of these two pointers? One pointer is indicating the frame number transmitted. Other pointer indicates the acknowledgement number received. Sequence numbers only. They represent the sequence numbers only. So two pointers. One pointer will refer the, in case of sender, one pointer refers about the information frame number transmitted. Another pointer refers the acknowledgement received, acknowledgement number received. So transmission, frame number transmitted, sequence numbers. Okay. So initially not transmitted any frame and not received any acknowledgement. So both pointers are pointing towards 0. 0 frames sent, 0 frames received. Okay. Then the same thing is in the receiver's window. Two pointers. So one pointer is, say this pointer is indicating frame expected frame number. Okay, expected frame number. And this pointer indicates acknowledged frame number, received frame number, sorry. Okay, this indicates received frame number. This is expected frame number means acknowledgement. So received frame number, expected frame number. So what is this thing? Received frame number is 0, expected is 1. Now receiver is expecting the frame number 1. Okay, received is 0, frame number 0 is received. Expected is 1. Okay. So the diagram B, now, so the sender has sent the frame number 1. Acknowledgement is 0. Received frame number is 0. Okay, acknowledgement number is 0. So 0 is received. Now is sending the frame number 1. So frame number 1 is sent. Okay, now sender has sent the frame number 1 in diagram B. But just the sender has sent the frame, but that frame is not yet received by the receiver. Still, receiver has not yet received any frame. So that is why the previous window is showing the same thing. The window is showing the same thing, not yet received, expecting the frame number 1, but not yet received. Okay, this is received frame number, still 0. The sender has just sent, but receiver has not yet received. Then the third diagram indicates sender has sent, that is same as the second diagram, but now receiver has received the sent frame. Now receiver, so indicate this edge, this pointer indicates frame number 1 is received. Now expected is frame number 2. Okay, so the window is readjusted at the receiver that it has received the frame number 1. Now it is expecting the frame number 2. Okay, it is expecting the frame number 2. That is the meaning of this particular one. And in the next two diagram, so what he has sent? He has sent the acknowledgement. Okay, now the sender has got frame number 1 transmitted, acknowledgement of 1 also received. Okay, frame number 1 transmitted, acknowledgement 1 received. So the window is adjusted, but it has not sent the next frame. It has not sent the next frame. So the receiver's window is not going to change. Okay, receiver window is not changed. Maybe in the next diagram, so sender, the pointer will be, one pointer is on the received frame number 1. So sent frame number will be 2. So this is how the next diagram at this point. Received frame, that is acknowledgement is 1. So sent frame is 2. That is what will be indicated at this point in the next diagram. This in the receiver place next diagram, same. Because just as sent but not yet received, so same thing will be repeated at receiver's next diagram. So this is how the sliding window is going to be used in communication between sender and receiver. Okay. Then next is 1-bit sliding window. So in 1 bit, there are two diagrams are there, A and B. Diagram A indicates the normal flow of frames between A and B. Okay, so that means one of them is starting the communication first, the second one is following up. Okay, so normal condition, that is one is initiating the communication and other is following that, accepting it. So in that sequence, so this diagram is indicating us, whereas the diagram B is indicates that more or less both are started at the same time. That's, see, now the communication channel that we are using is a full duplex. So meaning of that is while sending can be received, while receiving can be sent. So both sending and receiving can take place simultaneously. That is the advantage. So because of that, full duplex mode. Now here in this particular case, both A and B are almost starting the communication at the same time. So as a result, what is the ambiguity we are going to get? That we will see in this. So first, the normal procedure that we generally follow, one will start, other is following. Okay, in that concept, we will discuss what is happening. Suppose A is sending something. A is sending something, and in these 3 parameters are there. So these are the three parameters. So what are those three parameters is, so first thing, receive, so sending frame, sequence number. So first parameter indicates the sequence number. Second parameter indicates the acknowledgement number. And third is the data, information. Third parameter is information. So here A is sending frame 0. That frame 0 is having information is this. This is the information present in the frame 0. And this is the sequence number frame 0. And 1 is the acknowledgement from B. Okay, that means earlier A has sent something else, so that odd frame, so it is being acknowledged. So B might be acknowledged earlier in previous communication, so odd frame is being received. Okay, so that is the acknowledgement. So this initial acknowledgement, it can be ignored, but this point, so frame 0 A is sending this 0 is the sequence number, this A0 is the information present in the frame. So for understanding purpose, let us take it as A0 is the information that A is sending to B in frame 0. Now this frame comes to B. This frame comes to B. So the moment B receives this frame, what we will understand? So A is sending the sequence number 0 as the first frame. And A0 is the information in that frame. And A is acknowledging the previous transmission of B odd frame. B's odd frame is received by A. That is the meaning of this. That means now A is expecting from B its even frame. Okay. So what B is responding with this? B is sending, so frame 0, that is B0. And B is acknowledging A's frame sequence number. So A's sequence number is 0, so that is being used as acknowledgement number. I have received your frame 0. That frame 0 information is this, but the sequence number is this, that is nothing but this. Okay, this is the sequence number of frame received from A by B. So the same thing is being indicated as an acknowledgement. And B is sending its own frame information is B0 and the frame number is 0. So that B will send. Then that comes to A. The moment A receives, so from this A will understand that, so B is sending its frame 0 and B0 is the information in that frame, and B is acknowledging about A's frame 0. That means B has received this. So B is acknowledging about this. It has received it, okay. So as a result, now A will send its odd frame because even is received by B without any problem. So it is sending now odd frame. The odd frame information is A1. And A has received information from B is B0 is the information with frame number is 0. So frame number 0 is acknowledgement. Okay. A is acknowledging B's frame 0 and A is sending its odd frame. That comes to B. By the time B receives this, B will understand that now A is responding with the odd frame. This is the information, and A is acknowledging its even frame, that is frame 0, that is this. Okay. So A has accepted this without any problem. Now B will send odd frame because even frame is received by A. Now B will send the odd frame. And B has received A's odd frame, so it is acknowledging. Likewise, the communication is being taking place between A and B. If you see this, every frame is moving between A and B only once, no duplicates. Okay, here in this particular example, we will be assuming that channel doesn't have any errors. Okay, we are assuming that there are no errors in the channel. So everything that is being transmitted will be received without any errors. We will be keeping that in mind. So if we, by keeping this in mind, so in this situation, no duplicates, but the same thing will assume in this case also. Now let us see what happens here. We'll see what happens here. Okay. Now A is sending as usual like this. A is sending its frame 0 to B and its previous acknowledgement. More or less at the same time, B is also responding. B is sending its frame 0 with previous acknowledgement odd. Okay, information is B naught. Right? B has responded this, A is sending this. After B sends this, A is sending this. Okay? The moment B receives this, what we will understand? Oh, A is sending the frame 0 and this is the information. So A has received odd frame. Acknowledging odd frame means this is lost somewhere. B will understand because B has sent the frame 0 but A is acknowledging odd frame. A is acknowledging odd frame but B has sent the even frame. Frame 0 means B will understand this is lost somewhere. A has not received this. So that is why the same frame is repeated again. B is going to send it again the same. So frame 0, that is this sequence number, and information is B naught, same B naught. Now B has received A naught. So frame 0 of A, so it is sending the acknowledgement. Okay, B is responding with this. But before this, A will receive this. Okay, after sending, A is receiving this. The moment A gets this, what A will understand? Oh, B is sending frame 0. Okay. So with this, what B will understand? Oh, B is sending frame 0. B is sending frame 0. And B is acknowledging frame 1. But A has sent frame 0. So then now A will understand that this is missing somewhere. A has not received this. Okay. Then A is going to respond with the same again. The same thing will be sent again. Right? Then B will get that. Okay. Now with this, what B will understand? Oh, A is sending the acknowledgement 0 means, so B naught is received now. Okay. And A is sending A naught. That means a duplicate of this. Then we will think that maybe this is missing somewhere, not arrived. Okay. That is why, right? That is why, so it is not accepting. That is the understand this. Now again, B will send next frame. So A is acknowledging about frame 0 of B. Okay, B will think that, okay, this is fine. Right? Then it is sending the odd frame by acknowledging this. Right? Next, the moment A receives this, because after sending this response, A is getting this. The moment A gets this, so B is sending frame 0 and acknowledging 0. Okay. So that means again duplicate of this. Again duplicate of this. So A is going to send, A will saying that, so B has received the frame 0. So A is sending frame 1. Right? Likewise, the communication is taking place. If you observe this, every frame is transmitted twice. A naught is transmitted twice. A1 is transmitted twice by A. Similarly, B naught is transmitted twice. B1 is transmitted twice. Similarly, B2 also will be transmitted twice. So because they are not following one each other, they are trying to start simultaneously. So this problem has come between A and B. So though we are assuming that the communication channel doesn't have any errors, the communication channel doesn't have any errors, but due to mismatching in this, so though there are no errors, but the information is being exchanged between them duplicate. Every frame is being exchanged twice. Unnecessarily, that is increasing the bandwidth and other things. So this is the biggest problem in this. Okay, so that is why this should not be. So one should start, others should follow. If that is the normal sequence is being used without any errors, without any problems,